Alright, so this is my homework from last month. I didn't know anything about prototypal inheritance.
And now you know everything.
And now I know everything. Too much, in fact. Too much to understand JavaScript. So I've tried my best to strip away all the JavaScript, okay, build up prototypes, and then put JavaScript on top. And then you all can check my work. This isn't a JavaScript talk. But we're going to talk about prototypal inheritance. First thing I learned is that this is not called prototypical inheritance. That's something else. It's prototypal inheritance. So, did you realize that some things are more convenient with computers? Like, think of the chair that you're sitting on. Like, say, I wanted one just like that, and I told you, can I have a copy? That doesn't quite make sense. Or if your chair, you wanted to attach rockers on it to be a rocking chair, but you also wanted to keep the chair that you had, and you wanted to keep the original, so you wanted a rocking chair and the chair you had. That doesn't quite work. Let's say your chair, indeed the model of your chair was defective, and this model has been produced hundreds of thousands of times. And the person in charge of this is going to have to fix every single one. Wouldn't it be better if we could just fix them all at once? Hey, it's okay.
Yeah, another week up. Is this the one I got disinvited from? You do? I think so. I got kicked out without having joined it somehow.
Seriously?
Yeah.
I think so, yeah.
I'll show you the email.
Oh, yeah? Okay.
So physical reality is pretty inconvenient. And you missed it, but it's annoying. Computers are much better. Physical objects don't work like the way that we were just talking. In fact, computer representations of these objects are much more flexible. And in this talk, I'm going to talk about one particular kind of representation called prototypal objects. Yeah? Okay. So what is a prototype? So when I thought of prototype, I was thinking minimal viable product, scrappy, you kind of throw it away. It's actually not that far away, the word prototype, when it comes to prototypal objects. So when you Google prototype, it says a prototype is a preliminary model of something from which you base or you develop or copy things from it. And it's pretty close to what we think of as prototypes in the minimum viable product sense. This is also the case in prototypal objects. So let's go to my my question in my introduction. So I asked, I like that chair. Can I have a copy of it? And what can do? But let's see how we can solve that using prototypal objects. So a prototype is your chair, and I want a copy of it. So all we need to do is just point at your chair. The thing about computers versus reality is that computers have something called a reference that doesn't exist in real life. A computer can refer to something else. All I need to do to have a chair that's exactly like yours is to point at it. And this is how prototypes are used to create new things. And this is what inheritance means. Inheritance is about sharing. And if I want a chair just like yours, I just share the entire chair with you, or I inherit your chair. So I'm going to use a little bit of JavaScript notation, and it's very modern JavaScript. So the notation is, if we have a prototype, which is this chair, if I call object.create on it, I get my own chair. So object.create takes a prototype, and it gives you back an object with that prototype. So this is my chair, this is your chair. Does this kind of make sense? Yeah? Okay. Okay, so the question, for Karthik's benefit, the question was, I want a chair just like, you want that chair, but you also want a chair that's a rocking chair. You want both of them at the same time. You don't want to lose one. How do you do that with prototypes? So let's start with our four-legged chair. And that's our prototype. So we create an object from this prototype. And then All we need to do is change the parts that I want to change. And notice that your chair was not changed. I can do whatever I want. I can put a pillow. So this is, notice that we're describing objects in terms of their differences to other objects. And I'm going to have some pseudocode over here and some visualization on the right of what we just did. So what we just did was that we created an object which was a copy of the chair. And over here we have a prototype tree. And here's my chair, and its prototype is your chair. And I can put rockers onto my chair, and they only get put onto that chair. I can put pillows on my chair, and that only goes onto my chair. Does that make sense? Okay, thanks. Okay, the question is now, if your chair is defective, the company that made that chair is going to have to spend a lot of money because every single chair they made, they're going to have to fix. What if they could fix them all at once? So that was the question. How do we do that? So we can do that with prototypes using shared state. And the idea is that we start with a prototype, the prototypal chair, and say that we're at a factory and we create new chairs. So we basically clone the chair a bunch of times by just pointing at it. And we can do this as many times as we want. And now we have a shared reference point. And if we want to add I'm just moving away from the fixing a defect, but let's say that we want to make it prettier. That's the defect. Is that not enough customers are buying it because it's an ugly chair. So let's put a pretty pillow on it. So since the pillow is on the prototype, all the chairs that inherit this prototype also get this pillow. And we can put a rocker on this, and all the objects that inherit from this prototype get rockers as well. Okay, in pseudocode, we're saying that we can create two objects, and then if we go back up to the prototype and add a pillow, the pillows are going to be created. These objects inherit the pillow, and if we add a rocker to the prototype, the objects inherit the rocker. Good. So we've seen that objects are prototypes. So we have this prototypal object, which is a chair, and we use it to create more objects. And in fact, it's more general than that. Objects are prototypes, and prototypes are objects. They're the same thing. So what does this mean? Well, it means that we can have something like this. Say we had a party and there were 5 people and they all had different preferences for chairs. We could start off with the prototypal chair and say, well, let's create one chair that has a pillow, and then let's create another chair from that one, and notice that we're chaining on from the last prototype, from the last object. We're using it as a prototype, and we duplicate that one. Let's say that this one wants 2 pillows. And let's say we like this base, and we want to we want to make more chairs like it. So let's create 2 chairs like this. The one over here is going to get a rocker. The one over there is going to have a 3rd pillow. So this is what's called a prototype chain, or an inheritance chain. And this really underscores this idea of differential inheritance. My chair is like your chair, except blah. Then this chair is like that chair, except blah. You can keep going and going, and yeah. Okay, so in pseudocode, we can create the first chair. We can add a pillow to the first chair, and then we can use that chair as a prototype for the next chair, and then start customizing that next chair. So on and so on. I can't fit this entire. Does this make sense? Okay, good. Okay, so objects are more than just their state, how many pillows it has, whether it has a rocker or anything like that. We know that computers can do things, they can behave. And objects do this by passing messages around. So the way to think about that is every object having a mailbox. And let's look at this object for a second. It's got a red pillow. And by the way, if anyone's colorblind, I've tried my best to reorient the pillows and have different patterns, but if it's still not obvious, let me know. So we have this object. It has one red pillow, and this object has a mailbox. Let's say we want to get this pillow out. So the way to do that with objects is that you send it a message. You say, to object, can I get this pillow? And I've grayed it out because we can't see it yet. And then we put it in the mailbox, and then the object can say, oh yeah, I do have this pillow, let me send it back to you, and you can have the pillow. And this is the basis of how objects communicate with each other. But notice I haven't put any prototypes in here. This gets more complicated with prototypes. But before that, let's walk through the pseudocode. So if we have an object with a red pillow, and we ask for its red pillow using this sort of selector syntax, well, what's kind of happening is that we're sending a message into the mailbox saying, give me your red pillow, and then the object gives you the red pillow back. So this is very straightforward, very simple. Hopefully you all agree. This gets much more interesting when an object has prototypes. So the big idea here is delegation, and objects delegate to their prototypes to respond to messages that it doesn't understand. For example, let's say we have this chair here. It has two pillows. It has a prototype that has its red pillow. So this is a yellow pillow, this is a red pillow. And let's say the message here is, give me your red pillow. So this is sort of confusing, but give me the pillow that's oriented like a square. There you go. So this object can't respond to this because it doesn't own that pillow. It just points to the object that owns the pillow. So what's going to happen here is that we're going to delegate to the prototype to respond to this message. And then the prototype can respond with the pillow and then pass it back to the original object and then pass it back to whoever called that. So there's like prototypes are there to perform tasks for their children in a way. So in pseudocode, if we create an object that is like this single pillowed chair, we add a yellow pillow to it, and then we ask this bottom one, can I get your red pillow? What's actually happening is when we set up our mailboxes, we send the bottom object, the child object, the message, can I have your red pillow? This object doesn't know how to respond, so it asks its prototype if it knows how to respond. The prototype says, yep, here it is, I got it for you, let me send it back down, and wow, that was supposed to be a smooth transition. That's what was supposed to happen. So let me send it back down, and then send it out here, and this is the result of the program, basically. So this concept is called delegation. We're delegating to our prototypes to handle messages we don't understand. So objects aren't just about manipulating static things. Objects can do things, and the way to get an object to do something is to send it a message. So let's say we had a chair that has one pillow, but this chair knows how to count how many pillows it has. we can sort of, we have computers here. Right? This isn't an inanimate chair. This is a very smart chair. And now I can ask it, how many pillows do you have? Well, what's going to happen? It's going to use its current state, which is the number of pillows that it has, and send it to the calculator. And the calculator is going to do something and return the number of pillows that it has. So 1 in this example, and then 1's going to be the result. But what if it gets more complicated? What if there's more than one pillow? What if the pillow, one pillow's up here, the calculator's up here, and the pillows are down there? One important job of prototypes is to serve their descendants. Anyone who inherits from a prototype can ask the prototype, hey, do this thing for me, but pretend you're me. What does that mean? Let's say we have a chair that has 2 of its own pillows. It inherits from our smart chair. It doesn't have any pillows, but it happens to know how to calculate how many pillows it has. If I ask this object how many pillows does it have, it should answer 2, but we're calculating these pillows with this calculator. So attached to that message needs to be who was originally asked this question. So it was this object, like literally this. This is, you could think of this as the client of the request. It's called this a lot in Java and JavaScript. It's also called self. It's basically who was this message asked to. And this message, it's very important that we remember whose object we're counting. So when we mail this message, what happens is that this object does not know how to calculate how many pillows it has. So it's going to ask its prototype. So it sends it to the prototype's mailbox. And what the prototype does is very interesting. It takes out it uses the object whose it makes sure to count the correct number of pillows by using the correct object. So we're calculating this's number of pillows. And you can imagine how this could be disastrous. We could return 0.
The screen's a little misleading, right? Because the method is on the this that's being pointed to, but the state will be on the other one. Yeah.
So the method will be defined on the prototype.
Right, but the this is actually coming from the other one.
Yeah.
Okay.
So this other green arrow was trying to
say that.
Trying to say, like, you start off, when you ask the number of pillows, the first thing you do really is you send it here. But I guess the arrows are back to front. The first thing is you send it, and then the object says, oh, I'm going to ask my prototype, but I'm going to make sure my prototype knows who I am.
Right.
Respond to this message as if you're me.
Right.
Yeah, and then this arrow is out of order. Yeah, great question. Thank you so much. Okay, so let's say we've calculated the number of pillows. We should get back 2 because we are pretending like we are this person, this chair. So just like before, we package up that answer, send it back on its way, and we get 2. I think that's as complicated as it gets. All right, so what's the essence of prototypal objects? The first is that objects are prototypes. If you want to create an object, you've got to base it on a prototype. So I've really confused myself with the ordering of this. So let's just move past this sentence and go to this sentence because they are exactly the same. Yeah. Because not only can you inherit a prototype, but actually you can inherit other objects. You can keep going. Another essential characteristic of prototypal inheritance is that prototypes share their state with their children. So remember, if we add a pillow to the prototype, all the children will inherit that pillow. Objects in prototypal systems communicate via messages. So each object has a mailbox. And using those mailboxes, the prototypes can serve their children. So if the child gets a message that it doesn't know how to respond to, it can ask its prototype and attach on themselves. So then the correct client is provided. Does that make sense? I think I've hammered home this idea for this explanation. It's sort of bad. Okay, so JavaScript. This meeting is about JavaScript.
Yeah.
This meeting's name has JS in it.
It does.
And I fell for it.
It's misleading.
I fell for it and did a JavaScript talk, but it's not a JavaScript talk. So, what I really want to convey with this talk is a way to look at JavaScript that is sort of coherent. And one way to look at JavaScript is that it's based on prototypes and it has prototypes at the bottom. This wasn't always the case, as we'll come to. But if we look at JavaScript, at the bottom, we have prototypes, what we just saw. Prototypes with pointers to other objects, prototypes chains, message passing, that sort of thing. And if you know any JavaScript, these are the relevant things when we're talking about prototypes. Object.create, we saw that. That's the way to create an object from a prototype. This dunder proto thing, under proto, is, you can think of it as the pointer back to your prototype. This isn't really, I don't think it's standardized, but whatever, this isn't a JavaScript talk. Effectively, every object needs to point back to its prototype. This is what it looks like in JavaScript. So if you see that, remember, points back to its prototype. And functions have an implicit implicit client. And that's how we do that. That's how prototypes can be servers, can provide services to their children. They can make sure that this is rebound to the correct chair. Like, so we calculate the right number of pillars, for example. So that's the bottom of JavaScript. Now, this wasn't necessarily what was invented first in JavaScript. This is very recent, actually. At least the first part is. But that doesn't matter. We're in 2019. This is what JavaScript looks like. The next step up is this thing called the constructor pattern. And this is the part of JavaScript that's supposed to look like Java. And if you know any JavaScript, these are the keywords that you need to look out for. And if you're learning JavaScript, if you see these keywords, they're not at their essence about prototypal inheritance. New is a way to create a class. Like already we're talking about classes. I never talked about classes down here. So this is basically a facade, so then JavaScript looks a bit like Java. And if you see things like prototype and .constructor, instance of, think poor man's Java. Think poor man's Java. Don't think prototypal inheritance. And then on top of that, the most recent addition, as far as I can tell, I'm not sure when object.create was invented or added, is something called ES6 Classes. And all that is that keyword, class, blah, blah, blah. And this is a very thin, yeah, it's a thin abstraction to this. Yeah, it's a, I don't know if I should say the word macro, but it's a very thin abstraction to the constructor pattern. Everything you can do with this, you can do with this. Huh?
It sounds like a method.
Yeah, exactly. It's syntactic sugar.
That's the word. Yeah.
Thank you very much. What is a thinner abstraction than syntactic sugar? Okay, so you can see that it's very tempting. It gets uglier as you go up. So if you learn this first, you'd be like, oh, this is like Java. And in fact, it's not like Java, because this is based on prototypes. And if you come across something called polyfills, the only reason, so what a polyfill is, let's say we have a big inheritance tree, there's a prototype at the top, and we've created this elaborate program, and then we wanted to, and we depend on the prototype being able to respond to a particular kind of message, like how many pillows do I have? But let's say the previous version of JavaScript didn't allow that, didn't allow you to ask how many pillows you have. What a polyfill does is that it changes the prototype as if you were using the most recent version of JavaScript, and then that change propagates down. Now that is not Java, that is JavaScript. You could write that entire chain in terms of ES6 classes, but you could still mess with the top using this prototypal elegance or messiness. Yeah. Okay, so this talk has been about this bottom part. I have not talked about any of these things, but if you are new to JavaScript or are interested in exploring the relationship between these things, this talk has been structured so that you're able to relate each of these layers and not get confused by JavaScript as much. So that is the end of my talk. Thank you very much.
I think object.create was created in ES6 5, I believe. That's where
Good.
the course started.
So this was the latest.
And the idea of that is basically that you extend